Hi, welcome to the stoichiometry review. All right, so it's been a while since we looked at stoichiometry problems, so it's a good idea to review it. As a part of this review, you will be entering information in this graphic organizer, so make sure you have it handy. Let's begin with a definition of stoichiometry, and for that definition, you're going to fill the information in this middle box here. So what is stoichiometry? Stoichiometry involves using mole ratios to convert from the amount of your given to the amount of your find. So when we talk about mole ratios, there are two types. There are coefficients in balanced chemical equations and subscripts in chemical formulas. We're going to take a moment to look at these mole ratios a little bit more closely and review some examples where we use coefficients and some examples where we use subscripts. Now, we've already seen examples with coefficients before. We haven't yet seen examples with subscripts, so that will be somewhat new. But before we move on, make sure you take a moment to fill in the definition of stoichiometry in that middle box here. Okay, so mole ratios. There are two types, as I said, coefficients in balanced chemical equation. We use those when our stoichiometry problem involves a chemical reaction. And the other one, subscripts in chemical formulas, we use those when determining number of atoms in a molecule or vice versa. So let's look at some examples to make sure this makes sense. So looking at example A, we're asked how many hydrogen atoms are there in 1.00 mole of NH3. In this example, we're trying to figure out the number of atoms in a molecule, in a certain amount of NH3 molecules. And so in this case, we're going to use subscripts. There's no chemical reaction here. We're focusing on one molecule and the atoms within that molecule. So when I say subscripts, remember those are the small numbers here. And we can see from the chemical formula that there are 3 hydrogen atoms in one molecule of NH3. That means that there are also 3 moles of hydrogen atoms in 1 mole of NH3. So if you have 1 mole of NH3, you would have 3 moles of hydrogen atoms because the molar ratio is 3 moles of hydrogen atoms to 1 mole of NH3. And so in a problem like this, the mole ratio we would use to answer or solve this problem is the 3-to-1 ratio found here. All right, let's look at another example. So this is probably more in keeping with what you've seen before. In example B, it says how many grams of hydrogen are needed to react with 3.99 grams of N2 in the reaction 3H2 plus N2 goes to form 2NH3. In this case, the stoichiometry problem involves a chemical reaction, which is shown here in this balanced chemical equation. In the case when a chemical reaction is involved, we are using the coefficients in the balanced chemical equation. So since we're trying to find moles of H2 and we're given moles of N2, we would use the 3 moles of H2 to 1 mole of N2 as our molar ratio. Okay, we're going to take a look at one last example. And in this example, it's a little bit bigger, but I wanted to sort of introduce this up front. It asks if 14.32 grams of N2 react with 4.21 grams of H2 to produce NH3, what is the limiting reactant and what is the theoretical yield of NH3? And we're not going to read the rest because it's not relevant to what we're doing here in terms of mole ratios. But just that first question that we're asked there, example C, we are again dealing with a chemical reaction. I mean, keywords, reacts, produce. And they gave us a balanced chemical equation. So when you see that, you know that your mole ratios are going to come from the coefficients in that balanced chemical equation. And since this is a limiting reactant theoretical yield problem, you're actually given 2 givens, the amount of N2, 14.32 grams, and the amount of H2, 4.21 grams. So, and you're trying to find the amount of NH3 that can be produced from both of those reactants. So in that case, you actually have 2 sets of mole ratios, the 3 to 2, so 3 moles of H2 to 2 moles of NH3. And then the other one is the 1 mole of N2 to the 2 moles of NH3. All right, so what you're going to do now is you're going to fill in this box here using the information that you've seen in the previous slides. So you can pause the video now and get that information filled in about mole ratios, and then we'll come back.